We're going to go on to piecewise functions today, and piecewise functions mean exactly what it sounds like. We are going to take pieces of functions and put them together. So up till now, you know basically a straight line. You know an absolute value function. You know what a parabola looks like. And now what we're going to do today is take a little piece of each and put them together. So let's say we took a piece of line, but not the whole thing. And then we took some of the absolute value, but not the whole thing. And then we added onto it a parabola. So we get really weird shapes. But as you can see, there's 3 different colors and 3 different pieces of a function. So here we're going to work with this. We have example 1 here. And we have f of x, some function, is defined by 2 pieces, a pink piece and a blue piece. So I'm going to use tables to help me plot this piecewise function. And you can tell it's a piecewise function because there are 2 pieces listed here. So let's start with the pink one first. The pink one says that if I pick an x value less than 0, I have to use the pink one. The blue one says if I pick an x value greater than or equal to 10, I have to use the blue one. So I'm actually going to use a number chooser. So I have a number generator here, and it's going to generate numbers. And if I pick, first number it chooses is -8. All right, so -8. Does that mean I use the pink, or does that mean I use the blue? Well, -8 is less than 0. So I'm going to put whoops, let me change my color. I'm going to put -8 in the pink. -8 minus 2 is -10. All right, let's choose again. 0. Is 0 less than 0? No. 0 is greater than or equal to 0. So 0 would go in the blue. 0 squared is 0 plus 1 is 1. Pick again. 5. All right, 5. Is 5 greater than or equal to 0? Yes, so 5 would go in here. 5 squared is 25. 25 plus 1 is 26. Now, I'm just using numbers randomly. 7 is greater than or equal to 0. So 7 squared is 49 plus 1 is 50. So you get the idea. Now, let's look at my chart here. I've got my pink chart and my blue chart. And look at my axes here. These, whoops, let's use the right color. These x values here are all less than 0. These x values here are all greater than or equal to 0. So my pink and blue functions, there's 2 of them, so I have piecewise function. And we're going to just go right down the x's and figure out what this would look like. All right, so I'm going to clean this up over here, and I'm going to start with -10, -9, -8, -7, -6, -5, -4, -3, -2, and I'm just going to put -10 10 in here, so that's going to be negative 12, negative 11, negative 10. Are we seeing a pattern? All right, so now let's graph these points. Negative 10, negative 12 off my table. Negative 9, negative 11, negative 8 goes all the way down to negative 10. Negative 7 goes to negative 9. Negative 6 goes to negative 8. Negative 5 goes to negative 7. Negative 4 goes to negative 6. Negative 3 goes to negative 5. Negative 2 goes to negative 4. I think we can figure out negative 1 is going to go to negative 3. And what about 0? 0 can't be done in the pink. So we put 0 in and we get negative 2, but we realize we really can't put 0 in, so there's an open circle that goes there. Because even though we can't put 0 in, we can put all the numbers in up to 0. So all these are answers, and then all the way up to 0, we just can't include 0. So this is what the pink part of the piecewise function should look like. All right, so now let's see what the blue side looks like. I'll clean this up now, make this a little easier to read. If I put a 0 in, we know it's 1. If I put a 1 in, it's 2. If I put a 2 in, 2 squared is 4 plus 1 is 5. If I put a 3 in, 3 squared is 9 plus 1 is 10. If I put a 4 in, I'm off the page. So when I put a 0 in, I get 1. When I put a 1 in, I get 2. When I put a 2 in, I get 5. When I put a 3 in, I get 10. So I get a little bit of a curve, and this is what a piecewise function looks like. Notice it's still a function. If I drop my green line, the green line only hits each part of the piecewise function only once. Now you may be thinking, what about here on 0? Well, look what happens here on 0. It touches the blue function, which is closed, but the pink function has an open circle. So therefore, it means there's nothing happening there. So this is still a function. It only touches in one place. And it's really funky looking. All right, so we're going to look at the second and last piecewise function, but we see there are 3 pieces here. We have a pink piece, a blue piece, and an orange piece. So the pink piece says I may put the numbers negative 6 to 2 in, but careful, negative 6 and 2 are actually excluded, but I put them into my chart to help me understand where the function is really going from. My blue one says my domain goes from 2 all the way to 7. And my last one, my orange function, make that orange, says that I go from 7 to infinity, but 7 is exclusive. So now that I have my chart kind of set up, I'm going to actually just figure out what my values for y are, and then I will graph each piece of this function. So remember, this is 2 as an answer. In other words, if I put a negative 6 into here, my answer is 2. If I put a negative 5 into here, my answer is 2. If I put a negative 4 in there, my answer is 2. Put a negative 3 in there, my answer is 2. If I put a negative 2 in there, my answer is 2. I think you get the idea. Now, if I go to graph this pink one, it says go to where x is negative 6, go up 2, but I don't put a solid circle there because they told me my domain starts at the very next number after 6. So actually, that's why I put it in my chart as part of a thinking process. I actually put an open circle there. And sometimes when I'm doing this, I just put little stars next to these so I remember, tells my mind that they are excluded, but starting very one after it. So negative 5 is 2, negative 4 is 2, negative 3 is 2, negative 2 is 2, negative 1 is 2, 0 is 2, 1 is 2, and then 2 gets an open circle also. So now I could take a line, let's get a line over here, and I could join these. I'm going to make sure that line color is a nice pink one. Awesome. I just made the first piece of my function. All right, let's go do my blue one. My blue one says when I put x in here, I take the absolute value of it and then subtract 2. And I've got to do that for the numbers from 2 to 7. Absolute value of 2 is 2, minus 2 is 0. Absolute value of 3 is 3, minus 2 is 1. That's 2, that's 3, and that's 4, and that's 5. So now when I go to graph this, at 2 I'm at 0, but that's included because of this equal sign right here. 3 is 1, 4 is 2, 5 is 3, 6 is 4, and 7 is 5. And then they get to be joined with a blue line. Okay, and my last one, my lovely orange one, negative 7 plus 6 is negative 1, but remember, that is going to be excluded. That's my starting point, but it's going to get an open circle. I don't know why I want to change my pen to orange. So 8 would be negative 8 plus 6 is negative 2, negative 3, negative 4, negative 5. So I'm going to graph these points because remember, this goes on. So when I'm at 7, I'm at negative 1, but it's an open circle. When I'm at 8, I'm at negative 2. When I'm at 9, I'm at negative 3. When I'm at 10, I'm at negative 4. And I've run out of room, so I draw a line. But since this goes on to infinity, this gets an arrow. Notice none of these others got arrows because they did not go on. They did not go on forever and ever. So yeah, this is a funky looking piecewise function. But that's why we have piecewise functions. So we can make these odd shapes, and it's still a function because if I take my straight line and do my test, at no point does this green line cross any part of these more than once. Okay, so we're going to play tomorrow, Monday, or Tuesday, depending on when you're watching this video, making up piecewise functions. See you then. Bye.